Look at it. Small, silent, and for many, terrifying. Spiders. Over 50,000 species dominate our planet today, from the giant, hairy tarantulas to the deadly, elegant widows. They are everywhere, beneath the earth, in the corners of your home, and suspended from masterpieces of silk. What you are about to discover is not just the history of a predator, but the saga of a lineage that survived two mass extinctions that wiped out most of the life on Earth. It is a story that began nearly 400 million years ago. And every chapter is a lesson in adaptability, biological ingenuity, and proof that evolution favors silent innovation. The evolutionary journey of spiders is one of the oldest and most successful in the animal kingdom. It dates back to the Devonian period, approximately 380 million years ago, a time when terrestrial life was still in its early stages of colonization. The oldest known ancestor that foreshadows modern spiders is Atarcopus, an arachnid belonging to the extinct order Uraranida. Although not technically a spider, Atarcopus carried the seed of the revolution, silk. This proto-arachnid possessed silk-producing glands, connected to spigots on its abdomen. The silk, a remarkably strong, elastic, and flexible protein, was, however, primitive. Atarcopus did not build the complex webs we associate with spiders today. Instead, its silk was used for protection and habitat engineering, lining burrows, protecting eggs, and perhaps creating signaling mats on the ground. The absence of a fully developed spinning organ, the spinneret, distinguishes it from true spiders, but establishes a fundamental principle. Silk was born not primarily for hunting, but for survival and protection. This initial use of silk as a construction and security material demonstrates the early ingenuity that would define the entire lineage. The spider, as we know it, would only emerge millions of years later, at the end of the Carboniferous period. The first genuine spiders belonged to the Mesothelae group, which emerged over 300 million years ago. The study of this group is invaluable, as despite their antiquity, Mesothelae still exist today, living in the forest regions of Asia. They offer scientists a living window into the characteristics and behaviors of primitive spiders, functioning as living fossils. The dominant hunting strategy of the Mesothelae was ambush. They were terrestrial predators, building burrows in the ground, equipped with trapdoors and lined with sensitive silk threads. The silk at this stage functioned as a vibratory alarm system, a biological motion detector. The vibration caused by an insect touching these threads alerted the spider, which burst out of its hiding place in an explosive movement to capture the prey. It was with the Mesothelae that another crucial innovation was consolidated: venom. Connected to the chelicerae, venom serves not only to immobilize the prey, but also as a digestive aid. Spiders do not chew, they liquefy. Using powerful enzymes and digestive fluids, they transform the prey's body into a nutritious smoothie in a process known as extraoral digestion. This brutal and incredibly efficient tactic allowed spiders to hunt prey larger and tougher than their own size would suggest, conserving energy by waiting for the perfect moment to strike. Life is never easy, and the evolution of spiders was tested by global cataclysms. At the end of the Permian period, the Permian-Triassic PT extinction event wiped out about 70% of terrestrial vertebrates. The world was rewritten, and spiders demonstrated their adaptability, filling new ecological niches left vacant. From this period of restructuring and chaos emerged the Megalomorphae, the group that includes tarantulas, funnel web spiders, and trapdoor spiders. They are the tanks of the arachnid world, characterized by large bodies, robust legs, and fangs that point downwards. in an orthognathous arrangement. Mygalomorphae maintained burrow-based ambush hunting as their primary tactic, although some, like tarantulas, became more active hunters, using their strength and size to overpower prey. Most still rely on patience and surprise. Evolution in this branch favored power and terrestrial habitat engineering, perfecting burrows with trapdoors and silk linings that ensured hunting effectiveness and security. However, the quantum leap in arachnid evolution came with the emergence of the Araneomorphae in the Triassic period. This group, which today represents the overwhelming majority of spider species, is the most diverse and successful. They are distinguished by having fully developed spinnerets and fangs that move in a pincer-like labyrinthognatous arrangement, in contrast to the vertical fangs of the Mygalomorphae. This anatomical change allowed for more efficient prey handling and a more precise bite. The true innovation of the Araneomorphae, however, was the construction of complex webs. This adaptation was not accidental, but a direct response to evolutionary pressure. During the Cretaceous, flying insects were on the rise, becoming faster, more evasive, and more numerous. The terrestrial spider, dependent on ground ambush, was at a disadvantage. Evolution responded with the greatest arachnid invention, the aerial web. The Araneomorphae took silk, previously used to line burrows, to the air. The orb web, a geometric masterpiece, transformed the airspace into a passive hunting ground. The spider no longer needed to run. It built a perfect trap and waited. This innovation allowed the Araneomorphae to exploit a vast and previously inaccessible food resource, leading to an explosion of diversity. They specialized, adapting the shape and size of their webs for different environments and prey types, from the circular, sticky webs of orb weavers, designed to intercept flying insects, to the irregular, tangled webs of cobweb spiders, like the black widow, which capture crawling insects. Silk, which began as a protective material, became nature's most versatile hunting weapon, with each type of silk, dragline, attachment, sticky, being a different protein, optimized for a specific function. History repeated itself with the Cretaceous-Paleogene KPG extinction event, the asteroid impact that wiped out the non-avian dinosaurs. Once again, spiders, especially the Araneomorphae, emerged relatively unscathed. Their ability to feed on a wide range of insects and their protection in burrows or webs may have been crucial factors for their survival. In the Cenozoic era, with the proliferation of flowering plants and the subsequent boom of pollinating insects, the Araneomorphae entered a period of intense diversification and hunting specialization. Evolution, at this point, became an arms race of camouflage, mimicry, and highly refined hunting tactics. Notable examples of specialization include the crab spiders, which abandoned the web to become active ambush hunters, using camouflage to perfectly mimic the colors of flower petals, where they patiently wait to ambush unsuspecting pollinators. Another example is the bolus spider, which employs a master tactic involving chemical mimicry, releasing pheromones that imitate those of female moths to attract males directly to its sticky silk trap, which it swings like a lasso. There are also the jumping spiders, which developed incredibly sharp vision and hunting tactics that resemble those of a feline, pursuing and leaping onto their prey with millimeter precision. In addition to hunting tactics, spiders developed remarkable dispersal methods to ensure global colonization. Ballooning is a phenomenon where small spiders release silk threads that are caught by air currents, allowing them to travel long distances, crossing mountains and oceans, and ensuring their lineage spreads to almost every corner of the planet. From a crawling proto-arachnid to masters of silk, venom, and habitat engineering, the spider is a testament to evolutionary resilience. They survived cataclysms, adapted to every new era, and turned the disadvantage of not flying into a predatory advantage. Although they face modern challenges such as habitat loss due to deforestation and the decline of insect populations due to pesticides, the remarkable adaptability of spiders, evidenced by innovations like the web, specialized venom, and extraoral digestion ensures they remain among the most abundant and influential predators in the world. Their 400 million year history is a powerful reminder that in the game of life, adaptability is the key to survival. The spider, silent and ubiquitous, continues to write its chapter in Earth's history, a predator that, over the ages, has known how to transform the fragility of a silk thread into the deadliest of traps.